Okay, so hi. We are coming to you from Johnson Space Center, and this is Allie Westover and Glenn Johnson. Glenn Johnson is our lead for prototype and design, and I also help with the prototype and design and manage different areas of the country from Glenn. So we're going to talk to you about a little bit about the website, and then we're going to hand it over to Glenn, and he's going to talk about the hardware projects that we have going on, just to give a little bit more information there. So you'll see that our website has a lot of different information. When you start in the home page, we have kickoff videos that you can go to. We have a bunch of helpful links. We do have some expectations that we go through with our preliminary design reviews, our critical design reviews, and our web conferences, so please go through those. Anyone that's participating in the HUNCH program will have to fill out these talent authorization forms, and on this page there's information on how to do that. Material order sheet will come later, and you'll get more information from your mentors based on that. When we go to this tab, it's all about the design projects, and so when we come in here, we have our design projects, and we have a place where you can download it, and then we will be putting the video explanation right here that we're going to be making today. You'll see under this tab as well that we have project information and supporting documents. This page is dedicated to having more detailed information about the different projects, so you can see that. And then we also, depending on the project, we may have a separate tab. So like the work light documents and drawing files, and single and double ball clamp documents and drawing files. There's just a lot of files there. So we made a separate link for that. One thing to keep in mind about this website is that it's a living document. So we will be updating it regularly, so go in and check it out. We may be adding more projects as we go. We are definitely going to be adding more project information and supporting documents as well. The timeline information is over here. If your mentor has provided information on the timeline, then it would be under your area under one of these tabs. Former projects. This is a great area that has information about our different projects that we've had in the past and the schools that have been working on those projects, and it kind of gives an overview of the status of each of these projects. So as you can see, there's a lot of different projects that are working toward going towards space station. This tab, we will add things into the photos and videos, and if you can see here, we have a hashtag Hunch Design 2017. So as you take pictures of your projects or want to share anything about your projects, you can do this through here, and whenever we find those pictures or documents or videos, then we will attach them here. Okay? Obviously, if you have any questions about this website, please go to your mentor and they can help you find more information for you. So now we're going to go over to the design projects, and I'm going to let Glenn talk about them. We are not going to touch on the software projects today. We have a mentor that's out at Ames Research Center, and he is our software expert. And we will be talking with him and have a separate video that will just be for the software project. So today is only about the hardware. Okay, so I'm going to open this up as soon as it comes up. Okay, so you can download this file. It may take a little bit because we have a lot of information on this project PowerPoint. It's almost ready to be opened. Okay. Okay, and I'm going to make it a little bigger, but I'm going to give control to Glenn now.
Okay.
Okay. Are you able to do it now, Glenn?
Click
with your
to
mouse?
start the mouse.
There you go. You're moving it. There you go.
There we go. Okay. All right. So here, just notice that so this is just the intro page. Notice that we've got a lot of some on-orbit photos of some of our crew members, and that's actually the galley table that Hunch students helped design and build, and that's on the space station. Let's see here. Go next. Oh, how do I go to the next page? This one? Doesn't want to advance. Any ideas, Allie?
Okay, let me see. Have you used the down arrow?
Yeah.
Okay.
Each of my arrows, if I click on it, it doesn't seem to go anywhere.
There you go. You're doing
there
it
we go. Okay, I give it a swipe.
Okay.
That's a lot of swipe. Okay, let's see if I can go back. Is that it? Ah, let's see here. Okay, here we go. So some of our resources. So we have resources on the main web page, but we also included some here. So these are just some other resources that you can look through. You'll find that they're very helpful. They got some videos in some places and documents in other places. Okay. So one of our first projects this year is called the PMM Hygiene Caddy. And so the idea is that the PMM is the permanent multi-purpose module. It's one of the modules in the station, and we use it mostly as a closet. So it's a place where we store a lot of equipment, but it's also where some of the crew go to take their showers or do their hygiene to kind of get cleaned up. And so because it wasn't designed specifically for that, this area is lacking some things that would hold, like your towel, maybe your shower, your shampoo, maybe a body wash and things like that. And so we're looking to see if you guys could help us come up with some kind of a caddy that could be put onto the rack that you see in the center and that would attach to the seat track, so that it'll keep their towel from kind of floating into other people's faces while it's drying, and getting in the way. And also it needs to make sure that it keeps it off of a rack so that it doesn't cause mold on that in any locations. And so these are, so you can see a couple of pictures here that remind you of what kind of shower caddies we have on the ground, but those would not work on orbit. So we're looking for you to help us come up with some different ideas. And so at the very bottom there, you see that I've got a link that puts us to the Hunch Design project information. And not only is there information there about seat track and other ways to attach to things to the space station, there's also I'm expecting to have some more information specific about the PMM, and that'll come in a very short time. So check out some of the information that's on that other web page, and keep checking back because I should get some more information about um, uh, whether it's a specific rack or other information that might be helpful for that location. Okay. All right, next one. So I can get it to go. Let's see. There it is. Oh, too many. Hold on. Sorry about that. I have to be patient is the problem, I think. There we go. Okay, so one of the things that's interesting in space is that because you are not using the bottoms of your feet to walk around, those calluses will start falling off of your feet, and it's not always a pleasant thing to see. So what happens is your body continuously makes skin that will come off of your feet at some point. If you're using your feet a lot, those turn into calluses. If you're not using your feet, then it just is dead skin that comes off. And so the crew has complained that after about 3 weeks of being on orbit, a lot of those calluses start coming off, and they come off in fairly large particles, and so it's kind of gross. And so we are looking for ideas of how could we prevent all of this dust and debris that's coming off of their feet specifically from getting all over the rest of the space station. Because you can imagine that your buddy's foot skin does not need to be in your eyes or getting into your nose. And so it would be helpful if we could kind of clean it up in some fashion and get it thrown away before it starts floating around in the space station. And so here we've put a couple of different ideas up here. And so imagine if you have a coarse brush with with some kind of a scraper thing. If you start scraping that, you can clean off your feet, but now you're going to be sending it around in the module around the station. So that may not be very nice. But if it's on a vacuum cleaner, that might actually be good. It would collect, you would scrape it off and then get it sucked into your vacuum cleaner bags. However, you know, I think you need to be careful about how you do this, just because not everybody wants a coarse brush against their feet. They may need something different. Either it might be ticklish or it might be too sensitive on their feet. So we need to think about that. If you just had a regular brush, it would go all over the place. If you use a pumice stone, which is common on the ground, those particulate would also be bad for the space station, not just for people's eyes. And so we probably don't want a pumice stone, but it is something that we use on the ground, so keep it in mind. Now, some of the other things that we've talked about are having some kind of a booty that would go over their feet, and you might have like an abrasive lotion that would go in there. That might be a little bit difficult just because we'd have to verify that that lotion was okay on the space station. So anyways, these are options that we see on the ground, but you need to examine them carefully and decide if that's really something that's possible to use on the space station. And so open your mind up to big ideas and then start narrowing out and decide whether those are good options or not. And then how do you implement it? How is the crew going to use it on orbit? Do they have other things that is floating around going to be difficult for that? Are there particles that might come off and damage other hardware? So keep that in mind as you start going through ideas. Okay, the next one. Yep, almost got it. Okay, this one is a computer app, and the crew is looking for a way to be able to know what their location is as they talk to the ground. I'm going to let our computer specialist talk on that one. So just be aware that it's there. It's a pretty neat idea. There's our next idea. Oop, almost. Come on. There we go. Okay, now this one's actually really important, and it kind of surprised us. So we have these areas in the space station. We call them a radial bay, and what it means is that in node 1 and 2, we have in that particular module, we have a hatch on the forward side, a hatch on the aft side, but then we also have hatches that go to the starboard, to the port, and we have hatches that go to the overhead and to the deck. So in that area, we call this a radial bay because it has hatches that go in each of the directions. Now, the problem is that we have a module going in one direction, a module going in the opposite direction, so in the starboard and port, but we don't have modules that are attached on the overhead, and sometimes we have things on the deck. But because we don't have anything attached in the overhead, it means that we have this big open space that we store equipment in. And because that area is a great stowage space, we put a lot of things in there. The problem is that we also have some airflow vents that are getting blocked by some of that stowage. That because it's blocking that airflow, it means that we are not mixing mixing the air well enough, and we can get pockets where we get CO2 buildup, or maybe heat is building up in some areas that we hadn't expected. So the first thing you should say is, well, why don't you just shift this stuff up a little bit higher out of the vents? And the answer is that we had never planned to use this area for stowage, and so we don't have any little clips or anything to be able to pull the stuff up closer to the hatch. And so we're looking for ways that are simple and kind of cheap ways to be able to keep materials from getting in front of these vents that you see in the picture without losing our stowage space, and also without being a hindrance to, if I've got to get into that area in a quick way, I need to be able to get in. I need to have ways to pull whatever equipment that we make out of there easily without too much trouble. So down here at the bottom, I see I've got 3 possible methods to solve the problem. One is you can make some clips that will fit in there that would go on the screws. Another thing is that you could come up with these kind of vent hoods, and I've got an example of that in the left-hand side of the picture there, that might redirect that airflow. Or you might also come up with a bumper bar, something that would go. So if this is my vent, I might have some kind of a bumper that would prevent some of the bags from getting in the way. And we need to make sure that we're keeping bags at least 6 inches away from the airflow. Must be kept small so that they won't take up a lot of space. And they must be rugged so that if somebody kicks it by accident, it's either going to just kind of fall off and get out of the way, or it's going to be able to handle that kick and not be bent up and damaged. And it needs to be something that we can, I'm sorry. So one, we don't want to take up a lot of space with these things. And the other thing is that we need to make sure that we can take the stowage out of there pretty quickly. And I will have some more information on this in the next day or so, and I'll have some measurements and different dimensions for what that area looks like without the bags in it. Okay. All right. Next one. Oops, almost. Let's see here. All right. Here, so on the space station, astronauts get a lot of different types of food. We get there's 200 different kinds of American food that fly up. There's over 200 different kinds of Russian food that fly up. They get European Space Agency food, and they also get food from when the Japanese astronauts fly. They also bring up their own special food. However, most of these foods show up in kind of flexible packages. However, not all of them. And so some of the Russian food flies up in a can, like what you're seeing there, and some of the European Space Agency sends up food in a can, similar to what you're seeing. And so these are about the size of a cat food or a tuna can, that kind of thing. And so we are looking for a way to be able to squish these cans so that they don't take up so much space in the trash. And also, by squishing that can, you're also keeping any of that material that's left over inside the can from coming out and being a problem somewhere else. So now, the very first thing that Hunch flew to space was a can crusher. However, the can crusher that we made previously was a little bit too big. And so, and the crew, although they tried it for several years, after a while I said, this isn't really quite working the way we want. And so this gives you an opportunity to try to make something new. We're not looking for a great big thing. We're looking for something that is fairly small, but we'll crush the cans without leaving a whole bunch of sharp edges. And sharp edges are important. We do not want to have them. Also, we want to make sure that it flattens it fairly easily, and I don't want to have to do it a lot of times. So the fewer number of times uh, that we can grip the can and squish it, the better. We don't want to have to, do a little piece and then a little piece. I want to be able to get it done quickly. Okay, and part of the issue is that if I squish it with my hands, those edges are sharp. And so if we end up with an astronaut with a big slice on their thumb, that could be bad. We don't want them to get infected. We don't want them to be damaging or getting blood all over the place either. So this is kind of an interesting issue. Now this is one where you can start off with a 3D print of an idea, but at some point to be able to really test it, you're going to have one that's made out of metal. And how you decide how you do that, that's going to be up to you. It might be a welding project, it might be a machining project. There's a couple of different other options, or it might be that you take a regular pair of pliers and you start changing it so that it fits your needs. Okay, and so I'll try to put out some more information on another page for this one as well. Okay, so there are three more software ideas. If people are interested in doing that, I'm going to let uh, let Steve from Ames work on that with you. One more here. Oop. Sorry, hold on. I'm messing up. Sorry about that. Okay, here we have. So if you go on to our resource page, or also into the some of the projects that we've completed, a double ball clamp, which is what's right in the center, is a hunch piece of hardware. It's very exciting for us. We developed it for the galley table that you see on the right-hand side there. And that's my buddy Cliff holding the galley table that we have here on the ground that was built by hunch students. And there's one just like it on orbit. Now this one you can see is being held in place by the double ball clamps that are on the right-hand side of it there. And what it allows them to do is it allows the galley table to swivel. It can either swivel upwards, it can swivel downwards, and actually if you kind of hit it from the side, it'll allow it to kind of twist even. And the value of these is that they are a friction fit, so that when you bump into it as an astronaut, instead of getting a bruise on your leg or hurting yourself, the table moves instead of moving you. But it allows the crew to get the table into the position that they want it for use. They can swing it back up and get it out of the way, and they can swing it down to get it out of the way. And so it allows movement without having to take it off and manipulate different kind of clamps. And you can see that it gets twisted as in one of those pictures. So we are looking for other ideas of how to use this. And so we have two different ideas that we're working on, and I think that all three of these ideas are going to fly in the very near future. So the double ball clamp is going to fly very soon, and you can see that we have a ball clamp foot restraint on the left-hand side, and this is the crew asked if they could have a place to put their foot that would allow them to twist and turn so that they don't damage their knees. Okay, and so imagine like a strap going over the top of that, allowing the crew member to attach to it, be able to swivel their foot, and then also tilt their foot into different positions. We also have what we call the ball clamp monopod. If you know what a tripod is for a camera, a monopod is it's a camera pod with, instead of three legs hanging down, sticking down, it just has one leg, and you can adjust the height, and it allows you to kind of pivot. Well, we put one of our ball clamps on the bottom of the monopod, and it means that now the crew can use the same kind of idea. They can swivel and pivot their cameras into and out of the way, as well as to get them to locate and stay in one place while they're trying to work on a video or some other still shots and things like that, as well as having a piece of seat track on the side so that they can hold their lights, or maybe even a teleprompter, so that while they're talking to somebody on the ground, they can have their words right in front of them if they need to. Okay, so we're looking for other ideas that might be valuable on the space station, and the ideas where you might find some of these ideas by watching some of the videos that crews give of the space station. So as they float through the space station, they talk about what kind of things they like, what kind of things are fun, and sometimes you will get ideas about, hey, what about this? And those are things that we're looking for. Okay. Next one. Now, this one, I'm not sure exactly what we're looking for, and maybe I'll try to put some more information out here as I get it. But the idea is that not only is this double ball clamp interesting for on orbit, maybe there's a use for it on the ground. And so um, I gave you some question marks here because I don't know exactly what you're going to think of. But if your school decides, hey, we're going to print out a double ball clamp so we can see how it works, we have the information online so you can do that. You can print it out, have a double ball clamp, and then try and play with it and start figuring out what else could we do with this. So some of the thoughts I had were, could it be a hitching mechanism for a truck and a trailer? Um, could you would there be value between two boats? Is there a reason why I might use one of these double ball clamps to hold two boats together when they're out on the water? It would allow them to kind of swivel and pivot, but it would also keep them tied up together a little bit more rigidly than a boat would, or than a rope would. Okay. Um, uh, would it be valuable for using with a computer or and a monitor? So I don't have something to tell you to do on this one. This one is allowing you to use your open creativity and come up with something that maybe NASA has not thought of yet. Okay. Let's see if I can get it. There we go. Oops. Next one. Come back. We've gotten comments from the crew saying that when they take their trash and put it, let's see, let me back up. Supplies come up to the space station in something like a robotically driven rocket that shows up and it docks to the space station. When the crew opens that hatch and pulls all of the supplies out, they get their, they're getting food, they're getting batteries, they're getting oxygen tanks and different things like that, and they put those into the space station. Well, they take all of their trash and they put it into that rocket, that spacecraft, and when it undocks, all of that trash that is contained within gets thrown away. It burns up in the atmosphere. That's how we dispose of our trash. Unfortunately, we don't have trash pickup every Monday or every Tuesday like what we do here at home. They only get to get rid of their trash about once every month or two. And so you can imagine that any food debris or packaging and things like that, they might start stinking a little bit after all that time. And so we have these green trash bags that hold some of that stink in there. They keep the smells from coming out mostly. But imagine after 2 months or 3 months, all stink is going to get through it, right? So wouldn't it be nice if, so we take these little bags that have their stinky trash in them, and then we put them into this bigger bag, this blue JSB that we see here. That's a jettison stowage bag. And we take that, all of our small bags go into there, and then that one gets stowed in another module where it just sits there. And you can imagine that it starts to get pretty stinky after that amount of time. And even though those green bags hold most of the stink, they can't hold it all. This is just a cloth bag, and it keeps them all in one place, but it doesn't try to contain any smells. We thought it would be a good idea to ask you students to see if you can come up with a lightweight, simple method of taking this Nomex bag and seeing if you can make it so that it won't allow as much stink out. All right. How can you take a cloth bag that is very similar to cotton and keeping that smell inside. So there are a couple of different options that you might consider is, can I take that same bag design and then put can I put some plastic inside it? Can I line it with a very thin plastic that would help hold that smell in? Could I spray the interior with some kind of a airflow inhibitor? So uh, maybe like a Scotch Guard or something like that that doesn't allow airflow through that bag. And part of the deal is that I'm looking for something that when I fold up this bag, it does not make it a lot thicker. It doesn't make it a lot heavier, right? Um, we don't want to take up more. We don't want to take up a whole lot more mass. We want to take up as little mass as we can, right? And we don't want it to take up a lot more space when we fold it up. So we're looking for ways that we could take a Nomex bag and make it so that airflow does not come out of it as easily as it does today. Okay, and you've got some dimensions there. We're looking for simple ideas because we're not going to change this drawing very much. We're not going to change the style or size of the bag. We need to make it so that it works with the current design as easily as we can without a lot of changes. Okay? Let's see here. There we go. Oh, almost. Come on. I can do this. There we go. So this is not a new project, but it is a project that we are continually interested in. So here, on the space station, we have a couple of 3D printers, very similar to what you might have in your classroom. We are looking for ways that we can make tools with this. Now, right now, we can print a tool, but plastic is not very strong. It'll break fairly easily. Also, plastic is not very squishy, right? So I can't make a metal tool, a strong tool out of this, and I also can't make a gasket material. So that when I have two pieces of metal, and I need to have a seal between them, I can't do that. I can't make a seal for a hatchway using 3D printing. So we are looking for ways that we could demonstrate for NASA that that we can print a mold and then inject materials that make so that whatever it is that we inject in there, as it hardens up, it will be stronger than the mold that we made it out of. And so there are different options for this. Most of the plastic that we have up there is made out of ABS, but that is considered flammable. Just because you're in an environment where if I light that ABS plastic will continue to burn after I take the match away. And so that's a concern. We can't make a whole bunch of things out of this ABS plastic. However, there are some metals that melt at low enough temperatures, called Fields metal, that would allow you to inject it into this plastic. It's not going to melt the plastic, but it'll harden up. Now it's not super strong, but it may be stronger than the plastic mold. There are epoxies that we could put in there. There are like caulking material that could be put in there, and that would also potentially be done on orbit. Now the question is, we also have to worry about on the ground when you've got gravity, all of the liquid is probably going to sink down to the bottom of your mold. However, on orbit, you're going to have places where so without the gravity, any air bubbles could form in any location just because there's no reason for it to go up or down. It will just be in there. So part of the thing that you're going to have to be concerned with is, how do I get air bubbles out and make sure that I have a good, consistent, solid object forming in that mold? Okay, so we are looking for methods to be able to do this, and I have several ideas there on the right-hand side, as well as there's another page that um, for the project information that'll give you a little bit more ideas of what to do. Next one here. Here we go. Now this is an exciting one that is brand new this year. I was working with our friends at Glenn Research Center, the Hunch program there, and we came up with a pretty exciting thing. I don't have the final data on this, but I'd like you to start thinking on it, and I'll have data for you in the next day or so. But the idea is this: old fans make a lot of noise, all right? And right now on the space station, we have a whole bunch of fans on the space station that individually, they're reasonably quiet. However, when you have 100 fans that are all doing the same thing at the same time, they're noisy. And uh, we are looking for students to help us come up with some of the better designs that will be quieter. And the reason I need this is because we have some fans that are of a specific size, and we can't find fans that will fit that particular dimension that are commercially available. So I'm going to have some very specific dimensions for you guys to work on, and the question is, can you come up with a fan that is quieter than some of these old style fans that you see on the left-hand side? And you might be incorporating some of the different ideas that we've used in some of the new fans. So for example, a propeller from 1940s in a submarine was pretty loud compared to a brand new submarine propeller that we've developed. And part of the reason is because we changed the shape of that propeller slightly to be able to quiet it down. There's lots of information available on what makes fans quieter. And if you can help us design and make better fans, you could have a big impact on making it quieter on the space station, which would be terrific for all of our astronauts. Okay, and there will be more information. I will have a little bit more detail on specific motor size and fan sizes, things like that, and I'll have that very soon for you. Here we have another problem where on the left-hand side there, you see that we have a work light. These are the same kind of lights that they use in TV shows and movies to try and light up the scene. And so we purchased some of these and had them designed specifically for us. However, we found that the little tabs that hold the batteries on are breaking. Now, we're actually trying to move to another type of work light, but the process for us to find exactly what we want and to certify it and get it ready to fly takes quite a while. So we're looking to see if you guys could help us out with coming up with a temporary solution to keep these working a little bit better for the crew. So when the crew puts a battery on, you'll see that there's two batteries there. They're Canon batteries. They clip on, and because the back tab has broken off, they will often release. They don't normally float away, but it turns the light off. And so it's kind of annoying when you're working on something and then you lose the light that you needed so much. So we're looking for something that we could either 3D print on orbit or something that we could fly very small and cheap that would hold these batteries on better and keep them from floating away so that the crew doesn't have to mess with them over and over. Okay? And I'll have some more information on those for you. Sure. Oh, actually, that's already there. We have some information on the web page for you right now. Let's see here. Come on. There it is. All right. So here's an issue. You see that we send up lots of different foods in different types of packages. This is a continuing project that we're excited to have students working on, where we want to be able to send fresh fruits up so that the crew can have good food, kind of crunchy, crisp food, like whether it's apples or pears, or here you see some peppers and grapes, things that will last a little bit longer if we package them slightly different. Right now, we send up enough that the crew gets maybe a week or two, um, and we have enough food that the crew will eat it, and then they run out. So we're looking for a method to be able to preserve some of that food a little bit longer, so that we don't miss out on having crunchy food for the crew. There's a couple of different options here, and we'll see if we can come up with some more for you as well. Okay, I'm running out of time here. Let's see, few minutes. So, all right, so we have a pin kit problem. The pin kit is where we have some cables, some different connectors, and the problem is that as soon as the crew opens up this zipper package, some of these things float out. And the problem is not that that everything just floats all over the place. I think part of the problem is that we have too many things in there. And so we're looking for a method of taking some things and putting them into a slightly different package, but keeping it all together, so that we might have some things that are sewn, just like what you see here. But I think that there would be good pages, some other pages that have that might be 3D printed to hold some of the other objects. So for example, you can see that that alligator clip that's on the right hand side, instead of trying to hold it into some kind of a sewn thing, maybe it would be better to just clip it onto something. Or you can see that these are some wire splices. Those wire splices seem to float out of that pretty easily. So it would be nice if we could come up with some things where we've got a 3D print, and you can kind of clip it onto it and be able to hold it in place. This I expect to be a combination of an engineering as well as a sewing problem. So you might talk to some of, if you have friends that are in the sewing class, this might be something to collaborate on together with. We do a lot of sewing projects in Hunch because there's a lot of soft goods that go to the space station. Let's see. We are, let's see, the cupola is a set of windows that are on the bottom of one of the modules of the space station. And you can see somebody looking out of the one down below there. And you can see somebody kind of floating, that's Scott Kelly, floating inside the cupola. Now, the problem is that it's a fairly small space if it's just one person in there, or I'm sorry, it's a fairly large space if it's just one person in there. And they end up floating around, and they want to make sure that they don't bump into windows, and that they also don't, they're able to keep themselves stationary while they try to take a specific picture. And so we're looking for some way to be able to have a crew restraint, some way to hold themselves steady in that space. And if you look online here, we have some other examples to help help explain that location. It's a little bit of a funky place, just because we don't have something like that on the ground for you to explore. So we have a lot more information online for that. Whoops, almost done here. Okay, this is what's commonly called a bogan arm or a multi-use bracket. And the idea is that we have, when you loosen that locking axle in the middle, it loosens up both sides, and it'll swivel those ball joints at the end, and as well as rotate that center joint. A camera fits on one side, and the other side sits onto the seat track. Now the problem is that the company that makes these stopped making them, and NASA still wants some more. But we're not just going to make bogan arms. So we're looking for other options. If you have an idea of how to be able to hold a camera in place, as well as be able to allow it to pivot at different times, we're looking for your idea. And so you might first start with looking at what's online available commercially and see what kind of good ideas other people have if it would fit the kind of needs that NASA has for a new kind of camera holder. Okay, if we don't see what you want, then you start looking for other options. What else can we do? Okay, now the last page here, whoops, the last page has some more links for us, and this will just give you some more ideas of where else to go to understand. So if you watch some of these tours, listen to the crew, it's pretty exciting stuff. There's videos as well as reading information to help you understand how does a space station operate and what kind of things do we have. Allie?
Hi. Thank you so much, Glenn, for doing that for us. And I just wanted to say too that on the website that we have information on the Google map of the International Space Station, and that's an excellent source to be able to actually look throughout the space station and see how we set up things. So I think this is a lot of great information, and if y'all have any other questions, then please contact your mentor.
Excellent.